Hey guys, so I'm going to do a bit different here with this video. I'm going to take these rectifier diodes out of the circuit and replace them with these Schottkys. These are 200 volt, 20 amp. This is identical circuit to what that one is right there. So I'm going to take this one apart here to pull the diodes out of it and put these ones in, hook everything up, and then do some testing here, benchmark everything. So here's the circuit running like that right now. I'm going to hook this up like this, do all these, document this right now. That's the output voltage now. It's quite a bit higher. It's been charging for a while. And there's the current on the analog whenever all the LEDs are on. I'll take it off of here again and I'll just put it direct to the battery. Take this one off too to get it to start. There, now I'll get it to start. Oh, no, no wonder it won't start. There, it's on again. So this has been running for a couple weeks actually, and see the battery voltage has barely moved. This one's went up a lot. So I'll be back. Probably a long video. I'm gonna show you guys how I'm gonna do this too. Okay, I've got the diodes here. So these legs will be connected together right here. These two will be connected together. Two center ones right here will be connected together, and these two will be connected together. When the circuit's done, this will be the negative going to the output battery, and this will be the positive going to the output battery. And these will be the two AC legs on each side here. This is what it looks like on the paper. AC, positive and negative. So I'm going to put that onto the board now. Here, got it taken off. Get it all hooked up on the board. Okay, got them all here. Bent the way I think they should be. So the AC. So the AC's here on these two legs right here and right here. And this will be one of these, either one of these is positive and negative. I'll have to look back. Should be able to see here though. Okay, these are the positives right here, and these are the negatives. Oops. And this is EC, and this is the other EC. So this small wire here, I'll show you guys later when I'm just going to solder this in, and then I'll get the rest of the circuit here. Put it on here, solder this on quickly. Let's see, just a quick soldering job. I don't really need to flux with this solder I use. It's got a good rosin cord. This has a high frequency circuit, like so. Just gonna see, because I know the rectifier diodes are really slow. Not like they reject a lot of the voltages. I just want to see the difference here with these Schottky diodes. Try that. I should label these two right now. Should be positive. Negative. Okay, now I'll be able to just hook my leads up right here for the time being. Or I might actually solder something on here where it's easier to connect. This side here. This side I can connect right to the diode on the back there. That's also a positive lead. So now, this circuit, I have to pull these wires out and hook them up to that one. I don't know if I want to use hot air or what. Just snip it off or do this. Nope. Off. Okay, this one gets hooked to the collector. So I'm just gonna hook it up back here. insanely cold out here today. -36 right now. Tonight, I guess it's probably colder than that. It was a while ago. It was that temperature. So it's connected. And I think the next one goes to the base. Grab that one. The base is right here. I think that's this wire, this one. Just gonna snip it off. Somewhere right here. Nothing fancy, just as long as it has really good connections, it's all I care about right now. This, because I've never used the Schottky's with this circuit. Every time I built this circuit, I've used these rectifier diodes. In theory, the Schottky should work a lot better. It's surprising that the rectifier diodes even work in this circuit. But it could be one of the reasons why it does what it does with feeding the power back to the source. It's in there now. Last one is connect the other one here to the AC leg. This one that's left here. That's it. That one's off. And I'm gonna steal these LEDs and put them on the new one too. Put those on there. Some of those are here. To just grab a little couple little jumpers for the laser here, so I can hook up my leads a little easier. quick too. I don't want to have a super long video here doing this stuff for you guys. I want to do a quick benchmark on it too here, where the video is done. I'm super busy at work. It's hot. Negative hooked up. Keep waking up my hot air station. I'll turn that off if I need it. Okay, I think that's it for that. Unless I forgot something, but I think that's it. So I'm kind of rushing. I don't want to have a super long video here, so I'm going to put the heat sinks back on. I don't really need them unless I'm starting up some caps or something from a low voltage. That's when it pulls current, but I might as well just put them back on, and they're on anyway, so I don't lose them. And I'll be back. And just a quick cleaning here. Nice and purple. Okay guys, so I've got everything here all hooked up, bypassing the diodes here for now. Not tried it yet. It's only been about an hour since I've turned it off from the beginning of the video clip. Oh, where's your lead here? 60.29. This one here won't change much, but this is what 26.37, 36, 26.36. I started this test a couple weeks ago. It was 26.4 or something. I can't remember. By the time it rested, it was around 4 or 4 or something. I can't remember. Here, this one was 57.6, I think. So I've got the meters here. 0 volt. Bottom one is the output and the top one is the input. Five millivolts per division on the 1 millivolt per 10 milliamps setting. So all I have to do is turn this on. First of all, let's see what the LEDs do. Okay, you see already that's a big difference. See, the power coming out is a lot different. You can definitely see it's a bit different. The output is really good. So bypass these LEDs. Well, yeah, let's check the analog gauge first. Okay, that's the gauge here. Take the light off. There, it's off. On again. Off. On. Now I'm gonna just bypass it. Trying to get the circuit to start. That's wild. Sit running there. Put through the LED. Yeah, that's a lot of output. That's bright. That's the brightest I've ever seen it. The gauge hasn't moved. You see, by putting it through the LED, it calmed it down a bit, but there's still a lot of way more out on the output. I'll put it back. There. The gauge is hardly even moved a needle width, but look at this here. The bottom is the output. I'm going to leave this run anyways and see what happens with this. And I should be actually transferring that power back to this battery right now because this one's getting pretty high on the voltage. I'll just leave this run. See what it does overnight and see. But thanks for watching, guys. Been really busy at work. Can't really do too much, but trying to. I'm swamped with everything right now. If I could work on electronics all the time, it would be easy. Okay. Talk to you guys later. Bye.